You ever look up at the night sky and wonder, what if the moon just fell? It's a question people have asked for ages, and today we're going to dig into the science of what would actually happen. And let me tell you, the answer is way more intense and wild than you're probably imagining. Okay, let's get into it.
So first things first, right? Why doesn't it fall? We know Earth's gravity is pulling on it constantly. It kind of feels like some other force must be pushing it up, holding it in place. But that's not it at all. There is no other force. The real secret to staying up there isn't about pushing up. It's about moving sideways really, really fast.
And that sideways motion is what we call an orbit. The idea is actually pretty simple when you think about it. The moon is always falling towards the Earth, but at the same time, it's hurtling sideways so incredibly fast that it just keeps missing us. It's basically in a permanent state of falling around the Earth.
This ball analogy really nails it. Every time you throw a ball, you're actually creating a tiny temporary orbit. The only difference is that Earth's gravity and air resistance bring it down pretty quick. But if you could throw it fast enough, and I mean really fast, with no air to slow it down, it would just keep going, circling the entire planet. And that is exactly what the moon does. It's falling sideways at about 3,600 kilometers an hour, which is the perfect speed to complete one full orbit every 27 days.
Okay, so in the real world, the moon's orbit is incredibly stable. Even hitting it with billions of rockets would barely make it budge. So for our little thought experiment, we're going to need a bit of magic. Let's just say we cast a spell to hit the brakes on the moon, slowing it down just enough to make its orbit decay and send it spiraling towards us on a one-year collision course. Ready? Let's do it. So the spell is cast, and for the first few days, honestly, not much happens. The moon might look a little brighter in the sky, maybe confuse a few astronomers, but down here, life just goes on as usual. The only real effect the moon has on us from that far out are the ocean tides, and that is where our story truly begins.
You see, the moon's gravity constantly pulls on our oceans. It creates a bulge of water that gives us our tides, that gentle rise and fall of about half a meter twice a day. But as that giant rock in the sky gets closer, its gravitational pull gets stronger. A lot stronger. And this is where the trouble starts.
After just 1 month, the moon has already closed about half the distance to Earth, and the effects are becoming impossible to ignore. Tides are now surging 4 meters higher than normal. At high tide, major coastal cities like New York, Shanghai, and Mumbai are being swamped by massive waves every single day. Now, let's jump ahead to month 2. The moon has covered 2/3 of the distance. The tides are now roaring ashore at over 10 meters. We are way past simple flooding now. This is the beginning of a total global collapse. And what happens next is this terrifying domino effect. About 1 billion people live on or near a coastline. They are all now refugees, fleeing inland. The world's ports are completely underwater, so global shipping just stops, which means food shortages start almost immediately. The internet's underwater cables might be fine, but the stations on land that they connect to, totally flooded. 95% of the internet just winks out. Saltwater pushes up rivers, contaminating freshwater supplies. It's pure chaos. This timeline shows you just how fast things spiral out of control. By month 3, we're dealing with 30-meter tides. The moon's gravity is now so strong, it's literally pulling our communication and GPS satellites out of orbit. By month 4, 100-meter tides. At low tide, the oceans now retreat for hundreds of kilometers, exposing the seabed like a vast desert, only to come roaring back as a literal mountain of water. And then, after nearly 5 months, just when you think it cannot possibly get any worse, the real apocalypse begins. See, up until this point, the oceans have been absorbing most of the moon's gravitational stress, but they've hit their limit. Now, the moon's pull starts to work on the solid ground beneath our feet. We are no longer dealing with tides of water. We are now experiencing tides of rock and stone. The very crust of the Earth is being squeezed and deformed by these incredible gravitational forces. There are 2 things happening now that are just tearing the planet apart. You have the direct gravitational squeeze from the moon pulling on the crust, and at the same time, you have the unimaginable weight of trillions of tons of ocean water sloshing back and forth, putting massive pressure on the tectonic plates. The result? Constant, enormous earthquakes on a global scale. All this geological stress awakens the planet's inner fire. Catastrophic, climate-altering volcanic eruptions start going up all over the world.
We're talking places like Chile, New Zealand, and yes, the supervolcano under Yellowstone. These eruptions blast so much aerosol and ash into the stratosphere that they start reflecting sunlight back into space, turning the sky a haunting, rusty red.
At the 6-month mark, the halfway point in our year of doom, the moon drifts into the area where our geostationary satellites used to be. Here, its orbit perfectly matches Earth's 24-hour rotation, so for one entire half of the world, the moon just seems to stop moving. It just hangs there, motionless in the sky, like a giant, ominous eye. This creates a permanent frozen tide drowning one hemisphere under a massive bulge of water, while the other is left eerily dry.
The last few months are, simply put, hell on Earth. There are constant earthquakes, a volcanic winter, acid rain, and because the moon is so huge in the sky now, we have daily solar eclipses that have killed off almost all plant life. Billions of people are dead. And now, as an egg-shaped moon looms ever closer, we prepare for the grand finale. There's really no other way to say it. For humanity as an organized species, the clock has run out. Survival is now measured in hours, not years.
Towards the very end of the year, the moon reaches a critical point in space. It's a line called the Roche limit. At this distance, about 10,000 kilometers from Earth, our planet's gravity is now officially stronger than the moon's own gravity that's holding it together.
And this is the final act. The moment the moon crosses that threshold, it begins to disintegrate. First, rocks and debris from its surface start to break away and rain down on Earth. Then, the entire celestial body shatters into trillions of pieces of rubble. That rubble then spreads out, forming a magnificent, massive ring system around our planet, just like Saturn.
And just like that, it's over. With the moon gone, the source of the apocalypse simply vanishes. The insane tides stop, the earth-shattering quakes cease, the oceans pull back from the continents one last final time, and an eerie, profound calm settles over the battered planet. So, what happens next? Well, it's uncertain, but there are two very likely scenarios. We'll call them fire and ice. In the fire scenario, so much moon dust and debris rains down from the new rings that the friction heats our atmosphere to an insane degree, eventually causing the oceans to boil away. In the ice scenario, the giant shadow cast by our new rings, combined with all that volcanic ash still in the air, blocks out the sun completely, plunging the Earth into a deep freeze where the surface freezes solid. If any survivors managed to emerge from deep underground bunkers or submarines, they would be greeted by a breathtaking sight, shimmering, beautiful rings stretching across a sky that's now brighter than any full moon ever was. But as they begin the impossible task of rebuilding, you have to wonder, would they even succeed, or would they just be the last humans to ever witness such a beautiful and terrifying new dawn?